So today we are going to do a selection sort algorithm. So selection sort algorithm is a brute force way of sorting an array of integer. So for example, suppose you are given, let's say, suppose you are given an array that has 64, 25, 12, 22, and 11, and you want to sort this array using the selection sort. So for the selection sort, what we will do is we will iterate through all of these elements and find the minimum. So the minimum is 11. So we found our minimum, which is 11. So what we are going to do is we are going to swap this 11 with 64, the first position. So now our array becomes 11, 25, 12, 22, and 64. And now we are going to, now in the second iteration, our pointer will be at this position 1, and we'll start from this position and find the minimum from this elements. So the minimum from this element is 12. So we are going to swap 25 with 12. So the resulting array will be 12, 25, 22, and 64. Now for the third iteration, our pointer is here. So we will find minimum from this 3, which is 22. So we will swap 22 with 25. So the resulting array will be 11, 12, 22, 25, and 64. Now our pointer is here. We'll find the minimum, which is 25, swap with itself. So the resulting array will be no change because we are swapping 25 with itself. And now we have pointer here. The minimum is 64 itself. So we're gonna swap it with itself. So the resulting array will be 20, 12, 22, 25, and 64. So here we are iterating. Um, we are doing how many iteration. So here we are iterating through all the elements how many times? 1, 2, 3, 4, 5. So it's like number of elements. So we are iterating n times. So this is our first iteration, second iteration, third iteration, fourth iteration, fifth iteration. And within each iteration, we are iterating through all the elements which are again n. So our time complexity for selection sort is O of n square. Now, since we are not using any extra space, our space complexity is O of 1. So now, let's take one more example, which is, let's say you have a duplicates in your array. Okay, so let's do that. Okay, so now I'm giving you an array which has a duplicate. So I have 3, 2, and 1, and I want to sort this array. Let's consider this as 3a and this as 3b. So now when I sort this using the selection sort, so my pointer will be here. I'll find the minimum element, which is 1, and I'm going to swap this both. So now the resulting array will be this one, right? And then my pointer is here. I'm going to find the minimum and swap this both. So the resulting array will be, right? And then here it will swap with itself, swap with itself. So the resulting array is this. Now, if you notice here, um, here the order of this duplicate elements were 3a and 3b. That order has been changed when we have sorted our array using the selection sort. This means that the selection sort is not a stable algorithm because in case of duplicate, the order is getting changed. So, so selection sort is not a stable algorithm, which means that in case of duplicate, the order is not maintained. So now let's write the code for this one. So here, let's say we have a function and void selection sort, and the input to this function is an integer array. So now what we have to do here is, first what we have to do is we have to iterate for integer I is equal to 0, I less than array dot length I plus plus, and then here we have to declare the minimum because we want to find the minimum and swap the minimum element with our index, whatever the I is pointing to, right? So our min, we need to maintain our min index. So right, let's say our min index for this is currently it will be I, and then what we are going to do is we are going to iterate through all the elements starting from I and find the minimum. So for integer j is equal to I plus 1, j less than array dot length j plus plus. So now we are going to iterate through all the elements starting at position I plus 1 and find the minimum. So if we find any array element, if array of j is less than array of min index, which is our minimum element, that means what we have is we found the minimum element. So now we'll update our min index with j. So let's close this if loop, and then let's close this inner for loop. So now we have our min index. Now, sorry, we have found the minimum element by iterating this through all the elements. So the next thing which we want to do is we want to do the swap. So we are going to swap our array, and our two index are min index and I. So we are going to swap the ith index, the element that is at ith index with the minimum element. That closes this for loop and also our method. And then we can write one swap method. We can write private swap integer array integer I integer j. And then here in this swap method, we can have temp is equal to array of I, and then array of I is equal to array of j, and then array of j is equal to temp. So this is our swap logic. So for this algorithm, our TC, time complexity, is O of n square, and our space complexity for this is O of 1. So this is a brute force approach of sorting the elements using the selection sort. Thank you.